data. This is real data. Do you know IQs, if you've ever taken an IQ test, probably haven't now, but they used to be very popular. IQ tests are designed so that the average is 100 and the standard deviation is 10. And they've collected these data on lots of people. So we know that that's population answer. Now, if I'm going to draw my normal distribution, like that guy, agreed, middle, the mean is 100, that's where that goes. And you go 1, 2, 3 standard deviations. And if you go back 1, 2, 3, that would be basically the standard picture that this would generate, agreed? You start at the mean, you do your hill, you go 3 to the right, you go 3 to the left, and we are good. Now, let's look at some special z-scores. I think the book calls z-scores standard scores or some name similar to that. So if you ever see the word standard score, they mean z-score, right? It's just a different name for it. But here's the first one. The mean of the IQs is 100. What will its z-score be? Well, I'll write the formula for the z-score over here. X take away mu over sigma. What would the z-score for someone whose IQ was, say, 100? Right, so suppose they got an IQ that's the same number as the mean.
0.
Right. In fact, won't the z-score for the mean of any distribution be 0? Right. Because won't this number, your score, be the same number as the mean? And if you take two numbers that are the same, you get 0, right? And 0 divided by who cares is still 0. It's a 0. So that makes this guy 0. What would the z-score for 110 look like?
1.
And 2 and 3. What would the z-score for 90 look like?
-1.
And it wouldn't surprise you that 80 would have z-score of -2, and you would get that one for the 3. So do you see these guys here, the z-scores? Do you see how closely they follow the key pointers that you do when you draw a normal standard deviation with this mean and this standard deviation? So if you wanted to think of what is a z-score, you know, in English, when I get a z-score of 3 or 4 or 2.1 or any number, what is it? Well, one way of thinking it is, it's the number of standard deviations away from the mean. So if you have a z-score of 2, doesn't that mean you're 2 standard deviations away from the mean? And -2 would be 2 standard deviations on the smaller side. When you look at this set of data, I may have mentioned this, but it's good to mention it again if I did. You know that you only normally draw the picture 3 standard deviations either side. That's the kind of typical way to draw this picture. There are a couple of reasons for that. One is that it's easy, and you kind of everybody does it the same way. But what about all the other IQs that are not on that picture? Because they do exist. There are a few people out there with IQs of 140 and 150, right? Not many, right? They're geniuses, but they're out there, right? What do we call those kind of people that are way out here?
Outliers?
Outliers. Now, in this way of doing things, the standard normal distribution, can't you say that a person will be an outlier if their z-score is bigger than 3, or if their z-score is less than -3? So we can now do a test, a different test on outliers. So imagine that the average height of Scottish people was 65, and that the standard deviation of Scottish people was 3 inches. Is someone who is 72 inches tall, is that person an outlier? Right? Well, the standardized z-score is going to do that. 72 inches, take away 65, divided by 3. What does that get me? That gets me 7 divided by 3, and that gets me roughly 2 point, lots of 3s, right? So is a 6-foot person an outlier in Scotland as far as height? No. How about somebody who's 80 inches? Would your gut feeling tell you anybody who's 80 inches is probably an outlier, right? They'll probably play basketball as well, right? So they're 80 inches. But let's verify it by a z-score. 80, take away 65 over 3, and that ends up being 5, which is bigger than 3. And so the test, the z-score test for outliers is, if the z-score is bigger than 3, you are an outlier. And if the z-score is less than -3, you're an outlier. There was another test that we used way back in the day. Can you remember the test that you did a thing that looked something like this? And you did the mean and 2.5 standard deviations. Remember that test? It was a test for outliers, and what you do is you would get, I'm making this up, you get numbers like 60 to 80, right? And if it was bigger than 80 or less than 60, it was considered an outlier. And they had this arbitrary number 2.5, and I think I should have complained, and if I didn't, I'm now going to complain, that that is specific to this textbook. Because in Britain, that number becomes 3. And do you know if that number becomes 3, that's a z-score of 3 then.
I think you might have given us 1.5 instead of 2.5.
Oh, the 1.5 is the interquartile range one that you're looking at, and that's called the upper and lower fence. That's a totally different formula. I know it's got a 1.5 in it, but that's not this one. There is a different one that this one is, right?
And that's the 2.5 is what Americans use, right?
I think it's either what this book uses, or it may be what the Americans use. That's my excuse. I've got a feeling
it makes sense that it should be 3. Like seeing the bell curve, and it makes sense that it should be on a 3 instead.
Yeah, and you can tell why almost everybody that I know of, or every textbook I'm seeing or whatever, it may just, I blame the Americans, but maybe I should just blame this author. Because doesn't this author do histogram intervals really weirdly as well?
Yeah, they do.
Right. So, you know, sometimes you just got to live, you know, he's the guy that writes a book, or she's the guy that writes a book. So if they want to write it that way, you know, we have to follow the rules so we get the answers, right? Oh, which, by the way, in case I forget, do you know that section 2.1 with the histograms that I was complaining about, with the weird intervals? I am not going to put a midterm question with anything to do with intervals in it, just because it's causing everybody, including me, a whole load of grief. That doesn't mean, okay, it doesn't mean that I might pick a question that's got nothing to do with intervals. You know, the one where they give you a picture and they say, what kind of shape is it? Or is this guy an outlier? Those kind of questions are valid. Even if the intervals are weird, you can still answer those questions. But I won't give you one where you create the table or you create the weird intervals, because I just don't like the way they do it, and that's the end of the line. Do you see here that we have got a new test, which I think is a probably better test for outliers? Just find the z-score. If it's bigger than 3, you're an outlier. If it's less than -3, you are an outlier.
I have a
Now,
question.
yes.
Does that only work for the normal distribution, or does it work for like skewed left and right and everything else?
No. All of what we're doing in chapter 6, right from the start, has to be one of these shapes. If it's skewed left or skewed right, none of this works. Some of it is close to working. Can you imagine, because life is not white or black, right? It's a kind of grey area a lot. Can you imagine a question that's just a little bit skewed? Not a lot, but just a little bit. This would work a little bit. In other words, the answers won't be perfect, but probably usable. You kind of got to be a little bit generous because it's such a powerful technique. And so what you would say is, I definitely want this shape, but if it's a little bit more than one, it's so useful, I still want to use it because it's probably going to do really good information in the middle, and it might be a little bit more out when you talk about information that deals with things that are happening on the extremes. So in practice, what happens is that anything that is, I'll stick a classic word, approximately normal, we would run with it, right? We would use this analysis. We would use Z-scores. And do you know the ones we did yesterday? One standard deviation either side of the mean, 68% of the data. Two standard deviations, 95, and three almost all, or 99.7 would be better. Those would work, but you might be a couple of percent out. So instead of 68, it might only be 66. But at least you get a good idea of what's going on, right? Now, if it's really badly skewed, forget it. The answers will be so different from reality that you might as well just, guess a number and write it down because you're just as likely to be true. So, and you definitely don't want to do it with any distribution. I can live with a little bit skewed, right? That can handle, but never do it with a distribution that's just nothing, right? It just goes up and down like a yo-yo, and there's no rhyme or reason. If you try to use it on a distribution that had that shape, you try to use this technique, it wouldn't work, right? So you can get away with it for a little bit off, a little skewed right or a little skewed left. You could do it. Oh, how do you think they tackle this problem?
There was somebody asking if you can do another example of the last one.
Of the Z-score thing?
I believe so.
Okay, I shall definitely do that. Here's a little issue for you. Suppose that's your distribution, and you've got a little outlier here, just one outlier. Could you use this technique, the Z-scores and one standard deviation either side of the mean on this distribution? And the answer is yes, but you have to do one thing. Don't you have to kill that guy? Not use him when you calculate the mean and standard deviation. Because once T's gone, isn't it a nice shape? And all the data that you do. Do you know if you keep a Bill Gates, won't it make the mean much bigger? So it won't happen there, it'll happen over here because of this guy, right? So you see why you need to physically destroy them and not use them in the mean or the standard deviation. Now, I've been asked to do another example. So let's suppose the mean is 50 and that the standard deviation is 6. And I'll have this as a test, right? So this is the distribution, and the mean was 50, and it was 56, 62, 68. Going this way, it'd be 44, 38, and I think 32, right? So that's what the picture would look like. So here's one of the questions. Somebody got a score. Oh, darn it in space. Pretend you can't see that. Hide it. Because if I tell you this number, you're going to know whether it's an outlier, right? And I want to use Z-scores to do that, right? So pretend you didn't see that. So suppose I gave you, somebody got the score of 62, right? Are they an outlier? So the Z-score is the data, take away the mean, and that gets divided by the standard deviation. And the data is 62, and the mean is 50, and the standard deviation is 6, and I get 12 over 6. Oh, I didn't realize I was so nice. I get a z-score of 2. Is that number an outlier?
No.
Now, can you see that that number is not an outlier? Right. In fact, if you draw one of these pictures, shouldn't you be able to answer an outlier question just by using the picture? Right. But if you didn't want to do that picture because it was just a one-off question, wouldn't it be probably a little bit quicker just to use the z-scores, you know, just to do that?
Except for on the exam, you want us to show our work, right?
Yeah, and well, I would definitely want to see this. So you're
Yeah.
right. I take that back. In a homework situation, what you do is different from what you do in a test situation. You're right. Now I'm going to return back to this fella for a minute, and I'm going to do a totally different distribution. And let's suppose this distribution, the mean was 12, and that the standard deviation was 2. So in this picture, that guy is 12. This guy will be 14, 16, and 18. And going backwards, we get 10, 8, and 6. Right? So would you agree this is a total, although the shapes are the same, aren't they places where things happen totally different, right? The mean is at 100, here the mean is at 12. In this case, isn't the standard deviation quite big? It's 10. Isn't in this question the standard deviation is quite small? They're only 2. Right. Now, let's do z-scores of these key places. Won't the z-score of the 12 be 0? What's the z-score of 14 going to be?
1.
1.
Do you notice that when you convert these numbers into z-scores, don't you always get the same z-scores? 1, 2, 3. And that's not a coincidence, isn't it? 1 standard deviation away from the mean, 2 standard deviations away from the mean, 3 standard deviations away from the mean, 1 standard deviation less than the mean, 2 standard deviations less than the mean, 3 standard deviations less than the mean. Now, when they figured that out, someone went and said, there's one normal distribution that they all end up kind of looking like. And it's the guy that uses the Z numbers. Would you agree that that is also a normal distribution?
Yes.
Would you also agree that this is a very special one because the mean and the standard deviation are very simple numbers? What is the mean of this picture, this distribution?
0.
And what's its standard deviation?
1.
Yes. If you were making one, wouldn't that probably be one of the simplest combinations that you could possibly create? This one is the distribution of z-scores. And it's sometimes called the standard normal distribution. And typically when we say the standard normal distribution, we're really talking about this. And when I should be saying normal distribution, shouldn't I just be talking about guys like these two? So a normal distribution could have any mean, any standard deviation, right? But a standard normal distribution is this one unique guy. There's only one of him. There's lots of these. Now, this guy is going to become important. And it's going to be for this reason. If I give you the IQ one, I can get certain percentages. For instance, isn't 68% of the people going to have an IQ between 90 and 110, right? And aren't 95% of the people going to have an IQ from 80 to 120? And aren't 99% of the people going to have an IQ between 70 and 130? And you know, we did the cake thing where you cut it all into little pieces, and these two were 34 and all that. And that is good, but there's one big drawback about the cake technique, and I'm making that name up when I'm calling it the cake technique. But you know the bits that look like this, right? The picture that looks like that. Can you only find answers that use these numbers? You can only find what percentage of the people have an IQ from 100 to 120, or people whose IQ is 80 to 130. You can only use these numbers in your start and your finish, agreed? I couldn't, for instance, ask this question. So I'm going to do this on a new piece of paper. So you're going to have to kind of be patient for a minute while I write it down. Here is my IQ one again, because I like the numbers. There's 100, there's 110, there's 120, here's 130. Go backwards, 90, 80, and 70. Suppose I asked you, what percentage of people have an IQ between 90 and 110? I'm putting this in for completeness sake. If I asked you to do that, I don't want to write in this picture, wouldn't that be 68? Remember? Those ones you can do right now, right? Those questions, you know how to do them. But suppose I wanted to know, I'm not going to write the whole sentence. Suppose I wanted to know how many people have an IQ between 91 and 123. Well, if I did 91, it would be roughly what, about here? And if I did 123, it would be here. So you are basically trying to find out how big that piece of cake is, right? But right now, we don't have a way of doing that, do we? Do you see how this number is 91? Right? And this number here is 123. See the cake thing? It doesn't work for these, right? These numbers are in the middle of things. So there must be another way of doing it, right? And there is. And we use the calculator. So let's use the calculator. How are we going to do it? We are going to use a fella called Normal CDF. And this thing called Normal CDF has 4 numbers. The last 2 numbers are always going to be the same, at least in this section. The last 2 numbers are going to be 0, because that's what mu is, and 1, because that's what sigma is, right? Oh, darn it, rewind. We're talking here about a Z distribution. So in a Z distribution, the mean is 0 and this is 1. These 2 numbers here are going to be the low number and they're going to be a high number. You do not put in 91 here or 123 here. What you have to do is you have to find what they are as Z-scores. So essentially what we're doing is, do you see these numbers are 0, 1, 2, and 3, and -1, -2, and -3. We are going to find out what the Z-scores for 91 are and for what 123 is, and they're going to go here. And then I'll show you on the calculator where this fella is. And this function will tell us the percentage of people between here and here. Okay, so let's get started. I need to turn 91 into a z-score. So that's 91, take away the mean, and divide by the standard deviation. And I believe that is negative 0.9. I need to find 123. So 123, take away the mean, divided by 10, that's 2.3. So I am looking for negative 0.9, the low number, up to 2.3. So what happens here? Let's do a big picture. You want to know what percentage of people have an IQ from 90 to 123. What we're having to do is convert these numbers into what their z-scores would be. So now I'm trying to find what percentage of z-scores is between here and here. And that's the same thing as what we're originally looking for. The calculator is going to use these numbers in this thing called the normal CDF. You're going to use it to find the percentage of z-scores between negative 0.9 and 2.3. And the 0 and the 1 is because the calculator needs those numbers. So far, so good?
So the 0 and the 1 are always going to stay the same?
For your midterm and for section 6-2, yes. Later on, something else is going to happen, but I'm not going to talk about that because that'll just confuse the issue. Yes is the answer. Right now, the last two are always going to be 0 and 1, okay? Right now. And that's all you really need to know.
Could it be 1 and 0, or does it always have to
No,
be 0?
it must be 0 first, then 1. That's the syntax. That's the way the calculator needs to be put it in. If you swap them round accidentally, you'll know that you've done it because the calculator will say error, and you'll say, oh, okay, what have I done wrong? So I'm going to go and show you on my calculator how to do that. Right, are you all looking, hopefully, at a picture of the calculator? Right, now, the fella that's going to give us the percentage of people between 91 and 123, which is now turned into the percentage of z-scores from negative 0.9 to 2.3. So, make sure my calculator's on. If you look really carefully, I don't know how big it is, but do you see where the black button that says VARS, in faint blue above it, there's a thing called distribution, DISTR. See that guy? So blue button, that guy. So blue button VARS. You should be looking at this menu. Right. Now the one we want is choice 2. And then I hit enter. And my calculator is an emulator of the old version. Some of you might have a modern calculator. And in a modern calculator, this screen might look a little bit different. Has any of you got a modern calculator and you're not seeing what I've got? Right, so you're essentially going to do the same thing. You just put it in slightly differently. So the first number I have is negative 0.9. Now, I think in the modern ones, is there like a low and high or some kind of thing like that? Right, you'll put, oops, excuse me. Something weird happened there. Oh, I probably hit enter by mistake. Be careful, don't hit enter until you're ready. Right, so here we are back to this fella. So negative 0.9. I hit a comma. You'll probably just drop down to the next menu and you'll put in 2.3. On my calculator, I type in 2.3. And then I'll do, in my case, 0 and 1.
Do you know for the new calculators if we have to put it in parentheses as well?
Well, I don't know what you're saying, which is a bit of a pain.
So in yours it has it in parentheses, but in the my newer version, I don't know if you can see it, but it just
Move it
has
over
the
a little
list.
bit and look the other way. Hold on.
The other way?
No, you were right. Move.
Is that how?
No,
And to
move
the
the other way. Move to your left, or probably your right, because everyone's back to front.
Yeah, I think it's her
Yeah.
left.
Yeah.
Yeah.
You are what you're cool. Now it looks like your calculator has 2 more rows. Does it already say 0 and 1 in it?
Yes.
Then you're good to go. You don't even need to type it in because it knows that's what they should be.
Oh, nice.
Right? So what
Okay.
you then have, so you don't need commas or brackets or nothing. All you need to do now is go down to the bottom where I think it will say calculate. And to get to the bottom, you just hit the little cursor thing, right, until you get to the calculate.
Uh-huh.
In my case, I hit enter. In your case, you'll hit enter. And the answer is 0.805. You see it? So
Yep.
that's how you'll do it.
Okay.
Actually, maybe slightly easier is your new calculator does this a little bit less hassle. Yeah. Okay. So we have got an answer here. It's a decimal, but that's just the way the calculator works. Isn't 0.805 80.5% when you round it off and turn it into a percentage? Would you agree 0.805 is 80.5%? And we have just done our first fella.
So do I hit enter after I put that in the upper?
Yes. Joshua, if you're doing a calculator, you'll hit enter.
I keep hitting enter, and then it just keeps going down to all the rows, and then it went to paste. I want to say I had the same calculator.
Oh, I don't know what
You
you're
have
looking
to
at.
hit. You have to hit paste. You enter paste, and then it'll show it, and then you hit enter again. I know it's
Okay.
weird. It says so. You go down to paste. You hit enter. And
Oh,
then
no.
it'll-
No, he's not got your calculator. Right.
Oh, is it
Okay.
different?
Let me go back to my calculator, which is just like yours, because there's one thing you might have done that's the problem. When you were putting your original numbers in, it was negative 0.9. And it's this button here, not that button there. The negative is the one on the white. That may be what your issue was, right? So easy done, right? I'll need to go on the big screen here for a second. Right, you want to show me your calculator and talk, that way you'll get a major screen. Can you say something?
Yes, sir. I got it.
Yay!
I
We
was
are
hitting
cool.
the wrong button. I was hitting the subtract button instead
Yeah,
of
but-
the negative.
Hey, easy done. They look exactly the same. But you see that shows you how cool Zoom can sometimes be, right? Because if you were trying to do that by email, could you imagine the hassle? You know, it's a kind of visual thing, right? So
Yes, sir.
Zoom is not bad. Zoom is good, right? So I think what we need to do is get some practice at doing this, right? Now, if you have your own calculator, you might want to go and find it, and so that we can make sure that you're hitting all the buttons. If you're using the emulator that I've got, then you can certainly bring that up. It does the same job. And I just want us to get you really have to do it, because if you wait until this lesson is finished, you might have been in Joshua's situation. Hey, it's not working, right? And it wasn't a big deal, right? I'm not picking you, Josh, but I'm giving you as a good example, right?
Yes, sir.
So you want to make sure that you can do it right now, because I can guarantee you're going to get one of these in your midterm, right? So you need to be able to know what buttons to press and make sure that you're comfortable with, doing it, right? So I've given everybody enough time, I hope, to grab your calculator and, get ready for it. So I guess I'm going to have to jump. Yeah, question.
Oh, sorry. I just had a quick question for the answer of 0.805. You said it needs to be changed to 80.5.
I'm writing these answers down as percentages because most human beings like the answer that 80.5% of Americans have an IQ between 91 and 123.
Okay.
Now,
So
I can imagine the homework question, sometimes they will say, give me the answer to 3 decimal places, but they just want you to write 0.805.
okay.
So
I
look
was,
at,
I was, yeah. Okay.
Right.
Thank you.
okay. So we are going to do some, and let's see if I can, I'm lost of place here. Are we here? We are here, right. I'm going to go into Google. Oh, God, I got a better idea. Oh, I should get brownie points for this cool idea. It's a lot of pain for me to go out in any windows, so I'm going to give somebody in a few seconds here once I get the white paper sorted out. Here we go. If somebody could go on the internet and find, if it's possible, if not, I guess this might not work. I want you to find the average height of an American. So just do a Google search, something like average height of American. I just wanted to pick a question that had some relevant data to it. Hopefully it'll come up.
Yeah, according to Google or first one for abc.org, it says 5 feet and 9 inches.
Okay, so we'll just turn that into 69 inches just to make life easy. And it might not tell you the standard deviation, does it?
I don't believe it does.
Okay,
I make it
but that's fine. Let's just, this bit I'll cheat on. Can we pretend that the standard deviation is 5 inches? Just for argument's sake. I mean, that number exists somewhere, but I don't want to spend 10 minutes going through the internet to find it. So imagine then that we have the heights of Americans. I'm not going to be too neat on these guys because they take forever and a day to do. But can you do a 74, a 79, and then you finish with what, an 84? And if you go back the way you got what, 64, you get 59, and then you get 54. Yeah, that looks reasonable. Would you agree that the usual spread of people are probably somewhere in that rough range, right? So I don't think that's that far away from reality. So the reason I want that is just so that we have the ability to ask some questions. So how about a question like, what percentage of Americans are between, I don't know, 64 inches and 71 inches. Now, 64 is what, about here, right? 71's about here, so we're basically trying to find out how big that piece of cake is. So let's go through the steps that you would need to do that. I guess, wouldn't step one be to turn these two guys into z-scores? Because the calculator wanted z-scores, right? It wanted what they are. So this fella here will be 64, take away 69, divided by 5, and we get the answer -1. And the other guy's z-score, he's going to be 71, take away 69, divided by 5, and I believe the answer is 0.4. Now, imagine this is a midterm question. It would be really cool for you to draw this and to tell me these. And the reason you say, why do you need to tell me these is, do you know that when you get the questions in WebAssign, people get different numbers? So if I don't know what numbers you're using, I won't know whether you're doing it right or wrong. If I just suddenly see, you know, a different place, you know, if you kind of start too late on, it's hard for me to check if you got it wrong. If you got it right, I guess it wouldn't be such a big deal. And since the rest of this question is going to be done on the calculator, what you can show me is just the information that would go in the calculator. So in this case, wouldn't it go from the low guy to the big guy, and always 0 and 1? Does that make sense? So this would be stage 1 and this would be stage 2. So it's really a two-stage process. So far, so good? Right, now we're going to start, all of us hopefully, hitting buttons on calculators and hopefully all agreeing with the same answer. And then if we're not, then we'll try and fix, you know, why it isn't working, right? So here I go, clear out the old stuff. Second distribution, choice number 2, enter. My first number is -1, comma, My second number is 0.4, comma. My third number is 0, comma. And my last number is 1. And you finish with that little bracket. And in my version, you hit enter. And it looks to me like the number is 0.4967 and some stuff. If I round this fella off to 2 decimal places, it becomes 0.5. And if I turn that into a percentage, it's 50%. So let me show you what that looks like.
How do I clear my calculator to go back to just the beginning? I'm still on like where it says line 1, line 2, line 3.
Second quit. The blue button mode. Second quit.
A second. Whoa, I do not see that one.
Right. You have a button. Okay, let me go back. Are you still looking at the calculator?
Is
Yes.
that the squared button?
Right. So what you're asking me is you wanted to clear the screen of the numbers that are there?
Yeah, it says still the
Okay.
line. It's from problems prior, line L1, L2, L3. How do I get out of there?
I'm not sure how you get in there, but I can tell you how you get out of there. Right. The guy I'm calling the blue button, do you see that button there? It's blue. It might be yellow in your calculator. There's
It
sometimes
says-
different color.
Second
Yeah. And then see the button right next to it. It says mode.
mode.
Hit that one.
Okay, now it's nothing. Okay.
And is it done?
Yeah, thank you.
Right. Right. If you don't like the numbers that are there, you can also hit clear just so that you only have one set of numbers on your screen. Because I can imagine you might, if you have the whole screen full of stuff, that you might accidentally read the wrong digits when you're doing the answer. Right now, on the question that we have just done, but see, these are the kind of things that I think this is useful for, because you can imagine you're in the test and you're trying to do the same thing, right? You know, what the heck am I going to do here? You know, I can't even get out my calculator. Now you know, right?
Thank you.
Yeah, you're helping a lot of people, not just me and you. Okay. So what we're going to go back then is just show you what I just wrote. Hopefully we all agree that that's what your screen said, right? That's weird decimal. I just rounded it off to 2 decimal places and I got that. If they said round this thing off to say 3 decimal places, then it would become that guy. And if they wanted the answer as a percentage, then it would become that guy. Now, these answers are looking different, but aren't they correct according to the accuracy that we're being asked to do? So always read the question, do you want it 2 decimal places? Do you want it 3 decimal places? Do you want it as a decimal or do you want it as a percentage, right? Those little things just make life so much easier if you get them correct. Are we comfortable about the process then that we can use this new normal CDF thing to find the percentage of people between any 2 scores? Do you feel comfortable about how to do that type of question? Are we good? Okay. Then I will give you one to do on your own. Right, so I'm going to give you a question similar to this one, and you're going to go through it, and I'll wait until you've finished, and then I'll do it with you. So this time we're going to do a test where the mean was 80, and that the standard deviation was, let's make it awkward, 3. And I want to know what percentage of people got a score between 71 and 85. Okay, go for it. You got, I don't know, what would that take? You've got 2 minutes to do that question. You look deep in thought, Jenny.
I'm working. I'm just
Oh.
slow.
Right. Slow's the wrong description. I am careful. Okay, let's go for it. So I'm going to take 71 and convert it into its z-score. So I'm going to subtract 80, divide it by 3, and I believe you get -3. Agreed? I got a nod on that, so I'm good. The second one is going to be 85, and I'm going to subtract 71 from that. No, I'm not. I'm going to subtract 80 from it. I was scanning the wrong place. 85, take away 80, and I'm going to divide that by 3. And that's going to be, well, technically you have to type in decimals, you know, to the thing. So I guess we have to make a executive decision here. See if the z-score is one of those ugly decimals that just goes all over the place and never really stops. 3 decimal places is plenty accuracy. So you don't need to, if you've typed 10, 8 or 10, it's not going to be a problem, right? It's just more buttons than you needed to. So 3 decimal places is a decent accuracy for any z-score, any practical z-score. So now I'm going to move on to the calculator stage, and hopefully, I get it right. So second distribution, number 2, enter. My numbers are -3 first.
Where do you get the
Cool.
solution at?
We good? -3 first, comma, 1.267, 2 6s and a 7, comma, 0, comma, 1. Finish that off, and I am looking at 0.9508 and some other stuff. Is that what you got? 0.95. So I'll write this down right now. So the answer is 0.95, which is 95%. Do we feel happy about questions like the 2 that we've just done here? Do you feel comfortable now that if they ask you the percentage of people between this number and that number, you're turning them into z-scores, and then you're plugging the numbers into here, and there's the answer, right? That's kind of the stage. When you're doing homework version of these questions, you probably will not write all of this down. But in a test question, you know, because I need to give you partial credit if you're wrong, especially, and I need to check that you're not cheating as well. Can you see that's probably what I would like to see for that kind of question in a test? This would be the working. So if you're wondering what working looks like, that's what it looks like, right? And we'll talk more about that. But there are still 2 more versions of this that we haven't tackled. And here's the first one. So imagine I'm going back to my IQ again, because I like that one. And my little picture. We can do questions like, what percentage of people have IQ between 81 and 92, right? We've done that, right? Can I just say what percentage of people have an IQ between 62 and 75? Couldn't you do it now, right? We've got the process. Here are the two guys that we've not done. What's the percentage of people that have an IQ greater than 85? Now, do you see in this case, there isn't a second number. And you know that in normal CDF, you need a low number and you need a high number, right? Now, you can't leave it blank, which is what you might have hoped that you could do. And because it'll just say error on you. You physically have to put a number. So we're going to have to show you how to do that. Now, can I call the IQ X and can I call greater than 85? Is it not how you would write that down mathematically? If you didn't want to say it in English, this would mean the same as that, right? Now, step one is going to be exactly the same, except I only need to find one z-score. And we're going to do the normal CDF. And it's going to have a 0 and it's going to have a 1. And now we have to figure out what the heck does that look like? Well, if I take 85, which is here, and I write down its z-score, which is negative 1.5, aren't we trying to find that piece of cake? Right? Everybody bigger than 85. We're trying to find everybody bigger whose z-score is bigger than that. So, negative 1.5 or bigger. So, I need a number here. Wouldn't negative 1.5 to 9 or negative 1.5 to 99 or negative 1.5 to any number you like? And here is just my executive decision. In all the questions where you're being asked to find a score bigger than something, put the z-score here and choose 999. Now you might think, where on earth did that number came from? I made it up. It's a nice number and it is a big number and it will get you the right answer number. And the argument goes something like this. If this is your z-score of 1.5, if I stopped at 999, would you agree by the time you got to a z-score of 999, there's essentially nothing left? In fact, when you do a z-score, not that far after 3, isn't there nothing left? You know, z-scores 3 to negative 3 is pretty much everybody. If you go to 4 or 5, you're going to pick up the outliers. If you go to about 10, you're probably going to pick up Bill Gates. But you're not going to get much after Bill Gates, right? Even in the world, you're not going to get much after Bill Gates. So 999 is overkill. Do you know you could probably have put 9 and you'd get the exact same answer? In fact, when we go to the calculator, I'm going to do that just to show you. So if you don't like 999, do you know that you're allowed to put any number you like your birthday? As long as it's a big number. My birthday's the 25th, so I'm going to use 25 here, right? Something like that, if that helps. So now let's get into the calculator and start typing those guys in. And hopefully you can do it with me, and that's good practice for you if you do. Put on my calculator, clear that out. Second distribution, normal CDF, enter. Negative 1.5 or bigger, comma 0, comma 1, finished. You got your own version of that? Let's hit enter. It's about 0.93, which is what, 93%? It's me rounding off to 2 decimal places. Right. I'm going to take that fella and prove to you that the big number doesn't need to be 999. So here, the same calculation, negative 1.5 or bigger. I'm just picking 9 now. Do you know a z-score of 9 is really rare? It's Bill Gates kind of material. Comma, 0, 1, because it's always 0, 1. And have a look. Do you see any difference? Would you agree that 999 is overkill? You don't need all that. But, do you know why I picked 999? It's not an American reason. It's a British reason. Do you know if you phone the police in Britain, you use 999? In America, you do 911. Do you know that is freakishly weird to a person who comes to America for the first time and doesn't know that? Because if you think about it, any number, 999 is one example, but wouldn't 3 digits being the same be the easiest to type if you're panicking and you had to phone really quickly and you don't want to think about it? So what on earth made you think that 911 was a good idea? Has anybody got a made-up story for why 911 got chosen?
Because that's the emergency number when you call when it's an emergency or something's on fire.
Yeah, it is. But why couldn't that number not have been 999?
Because we want to be different.
With all of the information numbers that were made. So like 311 is information, 211 is for another.
Okay, so
telephone.
anything that finishes 11 is
Yeah.
an information, and 911 follows that pattern. That's sensible.
Yeah.
But then my argument would
411,
be,
that's right, Josh. Yeah.
my argument would be, then why didn't you have information numbers 111, 222, and 444, and then 999?
Because we as Americans have a chronic need to be different.
Do you know there's a lot of truth in that, I think? There is a lot of truth in that. And that is not necessarily a bad thing, because although you might think I'm picking on you, I actually love America. I think you're the best country in the world. Maybe Scotland beats you a little bit, but that's all, right? You are. And when I go home, I sometimes feel like I'm an ambassador for America, and I try and stick up for you. So I tell people, because people only get a view of a country by the media of the country that they live in. They get other views they get are through your movies and through your music, and that's true. But those things don't really convey freedom or how you live, right? I mean, if you watch a lot of movies, you might have thought that America was full of gangsters that shot each other, or drug-infested inner city depressing movies, right? Or millionaires movies, right? You get a kind of weird impression, and I found Americans to be really nice people. I like yous a lot. So when people say, "Oh, Americans are arrogant and Americans are, think you rule the world," and things like that, I don't have a problem with America ruling the world. The world is going to have superpowers whether America is here or not. And so my test is, if America disappeared today, what would the world look like? Well, China or Russia would take over the world. That's what it would look like. So you got to decide. You're going to be a superpower, you might as well have America. They're not perfect, but they're better than most. I definitely wouldn't like the Russians to control the world. That would be a scary place. And that's just me. So, oh God, imagine if Germany took over the world. Oh God, we'd all have to eat sauerkraut. And we'd all sound angry. To me, doesn't Germans sound angry when they talk?
That's
they don't
just
mean.
Because everybody listens to Hitler speaking German, and Hitler was an angry man.
Oh, okay, that's maybe true. But I think normal, everyday German sounds like they're angry.
I think if you hear a lullaby in German, it's hard to think of it as angry.
Ah, that's probably true. And Christmas carols wouldn't sound angry. It's just normal conversations.
I think Scandinavians like Norwegians should take over the world. You know
Oh,
their
God.
reputation. You know their reputations, right? Because I'm full-blooded Norwegian and my husband's full-blooded Irish. You know the clash of that one, right?
Oh God, you don't want to put those two together and rule the world. That would,
Yeah.
they would get drunk and start fight with each other. That
That's
would
my
not be a
husband's
good idea.
Irish and I'm Norwegian, so
No.
it's trust me, because you know the Norwegians are barbaric and they took over countries, and the Irish just literally bend over for the Norwegians. It's funny.
Yeah.
Yeah.
Yeah, if you go through the world, do you know if you made Switzerland the world leader and they took over the world, do you know that we would all have to clean our streets? This is true. I believe it's true.
Yes.
One of the professors was in Switzerland, and what they have is that when you live in a street, the pavement in front of you, it's kind of your job to look after it, so you have to clean them.
Well, look at the Irish. They were slaves when they first came here. They were treated just similar to a lot of the blacks. You know, they were slaves also when they first were brought here.
Yeah. Well, the Scandinavians took a lot of Scottish people as slaves as well.
Yes,
I mean,
we
that's
were
further back.
very barbaric and weren't the nicest people.
Yeah. You can't really base countries on what they did in the past, because if you did
Exactly.
that, everybody's got a bad reputation, right?
Yes.
The Italians were the Roman Empire. They weren't actually very nice to most
Yes.
countries that they visited, right? So we're all bad. We drifted. That was fun. I need a joke then. You ready for a joke?
Yes.
Because since you got me talking about Romans and such like, I'm going to tell you a joke about the Scottish and the English. Okay. Now, this is to show you the arrogance of the Scottish people. We've been fighting the English for about 1,000 years, and we've always been outnumbered 10 to 1. The population sizes of, there's 10 times as many English as there are Scottish. Even today, that's true. So the English army was coming up to the Highlands of Scotland, and they arrive at the beginning of the Highlands, and there's a narrow pass for them to go through. And so the English army stop, and they look at it, and the general says, let's send in a scout just to check it out, make sure nothing, they're not trying to pull something over on us. And just as the first scout's about to leave, this little Scottish voice says, send in 10 of your best men. I'll take them all on. I'll kill the lot of them. So the English general points at a bunch of guys, and they all charge in, and they go through the valley, and they disappear around the corner. And then you hear a lot of screaming and shouting, and it goes quiet. The little Scottish voice says, that was too easy. I killed them. Come on, send in 100 of your best men. I'll take them all on. I'll kill the lot of them. So the English general says, oh, we'll get this guy now. And he sends in a whole troop of guys. And they all charge in, and they disappear around the corner. And there's a lot of screaming and shouting, and then it goes quiet. And the little Scottish voice says, oh, that was too easy. Just send in everybody. Bring the whole lot of you. Bring in the army. I'll take them all on single-handed. I'll kill the lot of you. And so the English general says, oh, we're going to get this guy now. And so the whole army's moving towards this mountain pass. And they get about halfway, and suddenly one of the people who'd went earlier comes staggering out, and he's all covered in blood. And he shouts at the general, and he says, don't go, general, don't go. It's an ambush. There's 2 of them. Oh, come on. In Scotland, that's a hilarious joke. There's 2 of them. It's an ambush.
I was too busy typing out a recipe for sauerkraut. I totally missed it.
Oh, God. Well, it's not like a German ever did anything bad, Zoe, so go figure. Oh, come on. You must have got that one. It's not like a German ever did anything. Forget it. Okay. That Scottish joke died really badly, so I am going to have to do one more Scottish joke. This is a Scotsman and an Englishman, singular joke. And you got, you know the stereotype. So just to give you a stereotype, one of the stereotypes that Scottish people are meant to have is that they were very careful with their money, right? They're very tight with their money. They don't like spending it, right? That's a stereotype for Scottish people, amongst others. We drink too much is another one, and we fight a lot, so on. Actually, with the exception of the tight with your money, we're very Irish. I don't think the Irish have a reputation of being tight with the money. I think they have a reputation of they spend it all far too quickly. That's a different reputation. So that's the reputation of the Scottish. So a Scots guy and an English guy are in a really fancy restaurant, and they meet up for whatever business, you know, it's a business meeting. And they're talking away, and the Scots guy's looking at the menu, and, you know, it's lobster, it costs you, you know, $50, and it's T-bone steaks costing you $200, and it's all that kind of stuff. And the Scottish guy looks for the cheapest thing he can get, and it's, you know, a salad. So he orders a salad, and the English guy looks at the menu, and he starts picking, you know, lobster tail, T-bone steak, and caviar, you know, like whatever he could see. The Scots guy's looking at him. Anyway, they eat the meal, and they get to the end of the conversation, and the waiter comes over, and unfortunately the waiter made the bill out to one bill. And the Scots guy looks at it, and the English guy looks at the price of it, and Scots guy's thinking to himself, I'm not paying that money. And the English guy's thinking to himself, yeah, I'm going to wait. I can wait forever. I'm going to wait. That Scots guy's eventually going to have to pick it up and pay for it. And so they stare at each other for absolutely hours, and nothing happens. And finally, the Scottish voice says, out of nowhere, I'll pay for that. And while I'm at it, I'll pay for every single person in the restaurant's bill as well. And next day on the newspaper, there's a huge headline. English ventriloquist killed by Scotsman.
You got me laughing on that one.
Oh, I got you laughing on that one. Oh.
Yes.
Okay, God, we're drifting, but I drift. You know me by now, right? If you don't know me by now, you really aren't paying attention. So I want to show you one more example of that, because that's all we really need to do in a couple of tidy up bits, and then we'll talk about your midterm. Okay? So that is not the one I want. Let's try this again. This is the one I want. Right, so if you wanted to find the probability that you get an IQ score greater than 85, isn't this a process that we did, right? Now, I said there's two more ways. The next one is very similar looking. Suppose, oh, 70 is too small, 90, yeah, that's better. Suppose you wanted to find what percentage of people had an IQ not greater than or more than 85, but say less than 90. Now, in math, wouldn't less than 90 look like that? I'm still going to get the Z-score. The Z-score of 90 ends up being -1. And I'm going to do my normal CDF. And I have the same problem as I had before. Don't I need two numbers? But I really only have one. Now, if I do my little picture, I'll not put the details here, but can you imagine that's -1 and I want everybody over here, right? I'm looking for things less than 90, less than -1. That makes the -1 go here. Now, remember my executive decision. If you want bigger than a number, you put the number and then something bigger, right? If you want less, you put a number and something even more less, right? Something even lesser. Would you agree that this number here has to be something way over here somewhere, right? And what number do you think my executive decision puts here?
Negative 999.
Right? Or your birthday, right? They all work. And we're pretty much done then. So I'm going to go back out and go to the calculator, hopefully type it. And here we go. Clear these out the way. Second distribution, number 2, hit enter. And the numbers are negative 999 up to what, -1. Finish with the standard 0 and 1 that they all finish with. And in this case, the answer is about, what, 16%, 0.16. So about 16% of people will have an IQ less than 90. Now, in the olden days, IQs were used a lot more than they are today. And unfortunately, they were used in very, they weren't used very well. Do you know, this may have happened in the military in America, but do you know in the military in Britain, they used to use IQ tests or versions of IQ tests as aptitude tests, and that decided which branch of the military they would accept you into. So you know that someone who was going to be an officer, for instance, would have to pass an IQ test and have at least a certain IQ, or they wouldn't be allowed to be an officer. Or if you wanted to be, you know, something like an aeronautics engineer in the Air Force, you'd need to have a certain IQ. But if you only wanted to be like a military police in the Air Force, they would accept a different IQ. So they used IQs as like fences that you had to climb over, and before you would even have the opportunity to become that. And IQs are not designed really well for that job. Because IQs are a measurement of how easy it is to learn things. And it isn't even easy to learn everything. It could be that you have a brain that's very good at learning some skills and not very good at others. I'm a good example of that. It shouldn't surprise you, although with the mistakes I make, you might doubt it, that I have a pretty good brain for math things, right? I'm pretty good at conceptual maths and algebra and seeing things that are math things. I have an atrocious memory. So I would be absolutely useless at learning a foreign language. I would not be the top of the class if I was learning a foreign language. Because to me, I think one of the skill sets for a foreign language is, don't you have to have a good memory, because you have to memorize, for want of a better word, a lot of French words, amongst all sorts of other things like the rules of grammar and who knows what else, right? So can you imagine that the same person could have the IQ is not a good measurement of how easy it is for me to learn French. And another thing about IQ, it only measures how easy it is for that person to learn that skill. In other words, if you gave them it, they could pick it up in 20 minutes, where someone else it might take them 40. It doesn't factor in something which I think is more important, which is, what's the word I'm looking for? The opposite of being lazy. I can't think of a good word. Do you know if you're lazy and intelligent, you can actually be very intelligent and know virtually nothing because you haven't bothered, because you're too lazy to find out the answer to anything. Right? If you put your effort into it, right? So hard work, that's probably the word I'm looking for, is much more a measure of success rate in university and in your career than being intelligent. You might even know some really intelligent people who don't do that well. In fact, they don't even have a career because things bore them too easily. And so they can't really focus on something for a great deal of time. So if any of you go to university and you've had a hard time doing math, say, so when you go to university, you're going to get a class and you're going to have a hard time. But doesn't that mean you just work at it and you get it? So you'll be successful. Do you know what happens to a really, you probably met these, you ever had somebody in high school that really didn't study for an exam and still aced it? Right? Those people are very susceptible for dropping out of university. And that sounds like it's back to front, but it's not. Everybody, no matter how intelligent you are, aren't you eventually going to get some hard stuff that doesn't make sense and you have to work at it? Right, for normal people, that's usual. Don't you just work at it and you get it? But what happens to somebody who never had to study in their life? They don't have a skill set or the motivation. So they just say, this is boring. I didn't want to go to university anyway. I'm going to work at McDonald's or whatever. So that's my little spiel about hard work is better than intelligence, strangely enough. That's my experience anyway.
I have a quick question.
Yes.
For the problem of IQ less than 90, is it technically IQ less than or equal to 90?
Technically, yes, and technically no, because it doesn't matter, because they're the same answer. Okay. So you can say less than or equal to or less than, and it won't change a damn thing, because technically it's the same thing. Okay. Yeah, practically it's the same thing. It's not. Now, a couple of things. Am I on the white screen? I don't think I am I? No. So let me return to the white screen, and then we'll finish off. Oh God, I've got to be quick here, but we can overshoot the time if you want me to. I'm quite willing to do that. There's a couple of questions where I haven't spoken about, but we actually know how to do it. I just need to show you what they mean. Right? You're going to get questions where they tell you the mean and the standard deviation, right? And they are going to ask you to find or convert things like that, things like that, and things like this. That can be 86. And they're going to ask you to convert these into what they would be in Z-scores. In fact, haven't we been doing that today already? So all you would do is you'd take this guy and you'd say X bigger than 94, right? Getting an IQ bigger than 94 is the same as a Z-score being bigger than negative 0.6. And you just trust me, I'm doing it in my head. Right. That one would be getting a Z-score less than 0.7. And this one would be getting a Z-score between negative 2.5 and negative 1.4. So are you all comfortable that you can do this? Because we've been doing this already, haven't we? Right. So that they're just giving you some questions that are getting you to do that, getting you practice at converting bigger than, less than, or betweens that are written in X, right, raw data format, and converting them into Z-scores. Because don't you need to do that to be able to use the normal CDF part, which is what percentage of people are between those two? Are we comfortable with that? Now, here's a different question. Suppose the mean.
Question.
Yes. What you got?
Is it on the mu, like the mean, like where it says 100? Could that be a decimal? Like it's already.
Yeah, mu could be 7.3 and sigma can be nothing 0.5. I've just been
one of those with a decimal, please.
Remember, I'm not the drunk.
Sure. Okay. Let's suppose we had this fella, right? And I wanted to know X bigger than 8.7, right? Let's say that. So I want to turn 8.7 into a Z-score, essentially.
Remember, I'm not the drunk little girl I was before.
So I'll mute someone. There we go. So the Z-score is data, take away the mean, divided by the standard deviation. So in this case, it's a weird decimal. The mean is a weird decimal. And the standard deviation is another decimal, right? If you take that away from that, I believe you get 1.4 over 0.5, and that would turn into 2.8. So this would become Z greater than 2.8. So it's the same. I just picked nice numbers because I want to do it in my head quickly. But the process that we're doing works with really ugly numbers, right? Anything. The mean could be any ugly number you like. Couldn't the standard deviation be any ugly number you want? And couldn't the x be equally ugly? Won't it still be the same formula? And the calculator will do most of the work anyway. And a general rule, I think I've mentioned it already, but if you get a z-score that goes on forever, 3 decimal places is fine. If you round it off to 3, it will work perfectly fine. And we actually did one today, didn't we, to just show you that happening. One final thing, is that enough, or do you want me to do another one of that type?
We could do one more, please.
Okay. Have you got an example that's maybe a homework, or do you want me to just make one up?
Just make one up.
Okay, so let's suppose we have a mean of 75.2 and a standard deviation of 1.3. And I would like to turn the data 87.51, so I'm being really ugly with the data, into a z-score. Then the z-score will be data, take away mean, divided by standard deviation. So that would be 75.2, take away, I seem to be picking a lot of negatives today, that guy, divided by 1.3. Well, I'm definitely not going to do this guy in my head. Okay, I got my calculator here.
Wait, isn't it 87.51 minus 75.2?
Darn it, in space. You notice I didn't swear there. Do you know why I did that? I was far too quick for my own good. I mean, I actually said what I should have done, then I didn't do it, right? On my calculator then, I would break this into 2 stages. So I would do 87.51, subtract 75.2 first, and that comes out to be 12.31, and then I have to divide it by 1.3. So I'm now going to go divide by 1.3, and I am looking at a ridiculously high z-score, which rounds off approximately to that number. Are we good? Now, if you have any questions or any more of those, if you just wait to the end, I can tag it on there. But I want to do one last thing, and then we can talk about your midterm, because we are going to kind of getting short for time. Imagine that the mean is 20 and that the standard deviation is 5. Do you see I'm returning to nice number just to make things quick again, right? And suppose I told you that the z-score was 3. Oh, let's make it a decimal. Suppose I told you the z-score was 3.2. You're being asked now to turn that guy into the raw data score. So it's the reverse process. There are 2 formulas. The one that we've been using all day today is x taken mu over sigma. There is another one, and it is that guy. This is the formula that you use if you know the mean and standard deviation and I tell you the z-score. So in this case, the mean is 20. The z-score is 3.2 and the standard deviation is 5. And so this would be 20 plus 16. This would be 36. Now, the way they typically would do this question is they might just ask you what data would give you a z-score of 3.2, but they might turn it into one of these little inequality fellas. Suppose they said that, then wouldn't that become this fella? Suppose they wanted you to do that one, wouldn't this become that fella, right? So it's the same question, it's just like maybe put together a slightly more unusual way. So do you feel comfortable that if I give you some X scores, right, raw data, you can turn them into their Z scores and arrange them in whatever inequality situation they're talking about? Or if they give you a Z score fella like this, you can turn it into an X.
So does the second formula have a name? Is it just the X score?
I don't know a name for it, but you can make up a name. So
Okay.
for this week, it's going to be called Rachel equation. So the Rachel equation is that. And so that Jenny does not feel left out, this is Jenny equation, right? And we have two Rachels, so it doesn't matter which Rachel it is. We have a Rachel equation in the second one. Unfortunately, not all equations have names. But you might, oh, Rachel is happy with that. Rachel number 2.
You guys just cracked me up.
You're good. Right, cracking up is good, I'm assuming. Right, so next thing, we want to look at your test now, or midterm. So I want to spend as much time as I can, what's left, going over that result in the dashboard. And here is our class. Right, so I'm going to start at the end. Seems a strange way to do it, but our test is going to be from 9 till 12. Okay, so 9 a.m. till 12, and it's going to be on Monday, and it's going to be on WebAssign. And you're going to do your work on paper, but the answers are going to be put into WebAssign just like all the other answers that you do, right? So just like homework assignments. The difference is that when you do normal WebAssign homework, don't you get all those little added features that we were talking about yesterday, like give me another example to work on, or it sends you to the ebook where you can learn about it. That will not be on your test. You won't be able to see that. They won't give you those options. When you're doing your test, they vary the numbers. So you will not get the exact same numbers as the next person. And that's good because that cuts down cheating. I need to see you're working. That is going to be used to give you partial credit. It's also going to be used to check that you're not cheating. If you have to do a big question, and I know that that big question involves an awful lot of steps in it, and all I see is 42 in the box where the answer goes, then that's going to be highly suspicious, right? You had to do stuff. You can't do it in your head. Even if you can do it in your head, will you not do it in your head and write it down for me, right? Now, some things are a bit awkward to show me working. For instance, isn't a lot of today done on the calculator? So the only thing you could tell me was normal CDF, 1,3, that's fine. But wouldn't there at least be some Z-scores before that? So that would be working. You could show me where you got the Z-scores. Even if the Z-score is something you could do in your head, oh, it's going to be 2. I can tell that's going to be a Z-score of 2. Well, you still do it. Just write it down. I've designed the questions to last 2.5 hours. Or that's my goal. When I make it up, it'll say 2.5 hours. So you're all should finish with plenty of time. When you are finished, you have 1 hour to upload your working. So to remind you, can't remember what I've done here. If you click on this link, it takes you to a program that's called Adobe Scan. And what this will allow you to do is basically take pictures of your working on paper, and it'll convert it into PDF, a single PDF that you can send to me. And here's the link for it. And when you do the link, if you've got an Android phone, you can hit this. And if you've got an Apple phone, you can hit that. And that will do it for you. Once it's uploaded, once you've got your working as a PDF, you need to then upload it to Canvas. And I'm going to show you how that works presently. Make sure, are you looking at Canvas page right now? Okay, do you see that there's a link here that said midterm, that thing there? On the day of the final on Monday, I'm going to clear this page out. So the only things that are going to be on it are things like the download link, the midterm, and a PDF that just basically repeats most of the things I'm saying right now, so that you can have a quick look before the midterm starts, so you're aware. So I'm going to switch over here to student view. Should still be looking at it, right? Now,
Can we oh sorry, can we send you the Adobe PDF before the exam just to make sure that it works?
oh, go for it. You will know that it works. I'll show you me proving that it works. So you're going to do this. This thing here is open. It's live right now, even although you don't have your working. You'll click on it. And when you click on this thing, it will say submit assignment. And that's how we're going to do it, right? I'm going to show you by doing a pretend one, right? This is a little video that just talks you through it. So if you want to watch this video, it'll kind of repeat what I'm about to do. So if you want to do a practice, and practice are good, you'll hit submit assignment. And now do you see that there's a box here that used to not be there called choose file? Can you see that box? Because I remember it right. When you click on that, it's going to take you to your computer. So hopefully you've got your PDF already on your desktop, say, of your computer. You can do this from your cell phone, but it's a bit tiny and you could do it. But I would suggest email the PDF to yourself as an attachment, and then you can download it onto your desktop. That's the easiest way. So can we pretend that that guy up there is my PDF? Right? And you hit open. And do you notice here then that it says PDF? If you see that, it's worked. All you do to finish is submit assignment. Finished. Over with. Reasonably straightforward. Take pictures, use that Adobe to make it a PDF. It'll put it together as a single PDF. Maybe I would practice that, you know, write hello, how are you on 2 pieces of paper, take pictures, turn them into a PDF, get comfortable with the process so you know how to do it, right? Go here and download it. It won't matter what rubbish, what stuff, right? Because it's practice. I'm not going to see it anyway, right? So you download it. Here is something that could happen. Can you imagine on the day of the midterm, you take your 6 pages of homework, you turn them into a PDF, and you sent them, and everything's great, and you're walking away to have your coffee or your whiskey or whatever you do after an exam. Marie, you don't get whiskey, right? Yet. Coffee will do. Do you know this job has got me so PC, it's scary. I have to keep on qualifying myself as if saying have a whiskey. Oh, you told my daughter she can drink whiskey after my... You know I don't mean that, right? God, I'm drifting. God, I'm drifting. Right. You do your 6 pages, everything's great, you're giving your coffee, and oh, darn it, I missed 2 pages. I didn't realize that I didn't do them all. And now you're going to say, oh God, I'm going to lose a lot of points. He's going to think I cheated on the last 4 questions because there's no homework, you know, there's no working. What do I do? It's not bad. This is what you do. You get all your pages together again and you take them, including the 2 you missed. And you make a new PDF with all 8 pages. And you send it to yourself as an email. And then you upload it. And you go here and you hit resubmit. And then you pick the file that should have been. Say again, Cody?
What if it's after 1 p.m.?
Oh, don't do it after 1 p.m., please. I'll talk about that in a minute. You've got an hour to do it, so I'm assuming that you can screw up a couple of times and still have an hour, right? I mean, it shouldn't take you forever to do it, I'm hoping. So you just pick it again, and, oops, don't click it too heavy, pick it again, and go. Did I pick that? I did. And the cool thing about this is that it rubs out the old one and replaces it by the new one. So see if you've done a couple of practice runs and it's, you know, hello, how am I? I will never see them because they'll get overwritten by the good one. You're just doing it yourself, right, to feel comfortable. And what happened to the 6-page one? It disappeared because it got overwritten by the 8-page one. Right, so it's not that I have various copies of everything that you've uploaded. I only get to see the last thing you uploaded, and that's kind of cool. You feel comfortable about that process? Yes, Jenny.
I usually use a scanner and
Perfect, use it.
Okay.
Yeah, I'm just putting this here because I know a lot of students don't have printers with scanners. Scanners are great, do it. same idea. We're cool. Rachel.
I have a question about like worst case scenario, because a couple of times my internet has dropped out. What
Right.
happens if we're in the middle and our internet just maybe happens to drop?
Right, I'll do that, and I'll ask Cody, answer Cody's question. Cody, suppose you were trying to do it and Rachel's situation happened. You finished the test, but the internet dies on you before you had time to upload it, right? Can you imagine that happening, right? Or your hour goes by and you forgot. I don't know why you would forget, but let's say you didn't do it. And the backup plan will be that you will send it to me as an email attachment to my email address at whatever time your internet finally reloads itself up. So I guess you could have a power cut and you don't get it for 2 days. God forbid, don't do that. Well, it's not your fault, but just don't happen, right? So I might not see it for 2 days. But that's not going to happen, right? We're having positive vibes here. But if it did, that's how you would get around it. Now, again, connected to Rachel's issue, it could happen halfway through your test. That's even worse. So if you are in a place where you kind of have twitchy internet, right? Some of you, where I am, the internet's great. I never really worry about it. I worry about power cuts, but I don't worry about internet droppage. But if you are, when you go in, will you write down all the questions first on your paper? Say one question each piece of paper. Because once you've written it down, can't the internet die and it won't matter? Because you'll do your working on paper and you will send, eventually you will send the PDF to me and I will still have what I need. Don't do this, but theoretically, couldn't you go online, put 42 to the answer to every question in WebAssign and just send me the right working? Because what I do is I look at your working and I use that as your grade. And the WebAssign is to make my life easy. Because what will essentially happen is, if you did it right, you got 20 points. I look at the working, it's 20 points. I don't need to do nothing. I just need to move on to the next question, right? So it's less work for me to have the internet version of it. But I do need your working. One, stops cheating. Two, much more important, if you screw up a question, suppose the answer was 12 and you wrote down 21, or you added something and it was a little bit out because of that. You did 90% of it right, but you did a little mistake. WebAssign's going to give you 0 out of 20 because the answer is right or the answer is wrong. It has no flexibility. I look at your work and I'll say, yeah, she's 90% right, she's getting 18 points. Or she's half right. Because sometimes you only know how to start a question, but you don't know how to finish it, right? That can happen. Well, isn't 10 points out of 20 better than nothing? So can you imagine you might have a WebAssign question where you left it blank because you couldn't finish it, but at least you knew how to start it. So you're going to get partial credit on anything that you do, rather than 0, that is what WebAssign will do. So that's a big plus. So it's not just me stopping you from cheating. I do get, and you do get, advantages out of it. Now, there are exceptions. Do you know some questions are, here is 4 histograms, what shape is it? Hit symmetric, hit left skewed, right skewed. Do you know those kind of questions where you look and you, I don't see working for that. I never will see working for this, right? I don't expect it, right? But almost everything, can you at least do some working? So show me what you're doing. Even if the calculator does most of it, you know, show me what you're doing as much as you can, and that will be good. Your midterm is chronological order, which just means the first questions are from week 1, right, the intro to data. And the last question that you are going to see in your midterm will almost guaranteed to be, what's the probability that you get an IQ between 87 and 92? You know, the stuff we just did today, right? So when you look at the midterm, it's going to be WebAssign questions. So when you look at them, they're just going to be, WebAssign's the people who make them. I just pick them, right? I mean, they got a big list of them and I just pick them, right? So there won't be, because I know it happens to you. Sometimes you do, I'll blame chemistry. You do chemistry homework, you do chemistry stuff, and then you get the test and they ask it in a way that you've never heard it before. And that can just throw you for 6. Well, you've been doing WebAssign homework questions. You know how they ask them. You're just going to get some more questions like that, right? So you shouldn't have that transition issue.
How many questions will there be?
I have no idea yet, because the way I do it is WebAssign will tell me how long a question takes. I will design it so it takes 2.5 hours. And that could be 15 questions. It could be 20, it could be 10. You know, can you imagine a question that says, here's a histogram, which one is it? Do you know that would take about 2 minutes tops? You know, you just tell me what the picture is and your 4 choices. So that would be a question, right? But wouldn't it take 2 minutes to do? On the other hand, couldn't you do one of these? You had to find 2 Z-scores and you had to do this and you had to do that, and it could take you 10 minutes. So you see, the questions are not, they don't take the same amount of time. So I don't know yet until I start building it how many it's going to be. But what I can promise you is that 3 hours will be half an hour more than you need, at least according to WebAssign. But if you do take your time, if you are careful, do the easy ones, the ones you know how to do first, because you'll do them quickly and that'll guarantee points in the bank. And then you can worry about the ones that you have issues with. And for the ones that you have issues with, even if you only get halfway through, I know you'll leave the WebAssign answer blank because you don't know what the final answer is, but at least haven't you done the working for the top half, and with a bit of luck, you'll get 10 points out of 20 kind of thing.
Will the exam automatically close at 12?
Yeah. It will automatically start at 9. And so if you go into WebAssign at 1 minute to 9, you won't see it. So you might want to wait to 2 seconds after 9 just to be sure, right? And when you go in, it will be there. It will just appear just like homework does. It'll just say midterm exam. It won't be hard to tell. And when you enter it, I believe it has a little clock that goes 3 minutes, 2 minutes 59 and all that carry on. I was told by a student it distracted the heck out of them. So get a piece of paper or stick something over the bottom left-hand corner and hide it if that you don't like the pressure of seeing a clock ticking as you're doing your test. But it is there because you do kind of need to know how long you've got. And it'll do it like that 10, 9, 8 down to the bottom. Cancel. If you think you're running short of time, let's just do a scenario. Let's say there's 2 questions to go and you can look at the clock and there's 5 minutes to go. Couldn't you just write down what those 2 questions are in that 5 minutes? Do the working on the paper, and then when you upload the working, because you have an hour, right? So there's a little wiggle room in time, and you could do that and send it to me, right? I hope it doesn't happen. Typically people finish my exams on time, right? But just in case it does, because maybe there's a really stinking question and you spend half an hour trying to figure it out, I probably wouldn't do that unless it was the last question in the test, right? Do everything else before you do that question that's going to take you forever in the day. And, hey, you can still do really well and screw up a couple of questions. You'll still get a decent score. Your homework, from what I've seen, with a few exceptions, I believe WebAssign gives you a running total of your percentages, doesn't it, as far as homework goes? So you kind of know that you're a 94 or an 87 or a 100 or whatever your number is. That's part of your grade, so you've got a good buffer right now if you've got good homework grades. And I know some of you have done the, it's something that's Canvas, Intro to Canvas, and you've sent me your thing. That gets you some extra credit as well. So that'll be added onto your grade, so everything helps. Any other questions?
When will we know our score? Like after we submit it, will we know immediately what our WebAssign score is for the
You
answers,
might,
or?
but don't look at it because it'll scare you. Because
Okay.
WebAssign will tell you you've got 50%. And you'll think, oh God, I've bombed that exam. You won't end up with 50%, trust me. I've done enough of these to know that that's not what you're going to end up with. Once I've done the grading and the partial credit and all that, nobody ends up with the same score that WebAssign gave them. Everybody always gets more because WebAssign just says you're wrong, you've lost 20 points. You know, it doesn't take much before that makes you look horrible. So you'll probably know instantaneously. I think that's what it does, but just don't look at it, is my advice. Or at least don't pay attention to it. I mean, if it says 100%, I'll take that back. Pay attention to it. If it says 100%, that's a great thing, right? But if it says 50%, ignore it, right? Because it's not realistic. Probably realistic on a high percentage because it means you must have done it right. I just need to make sure the working is right. Any other questions? We'll do Kelsey first then. What you got, Kelsey?
Sorry, it's just about the Canvas orientation certificate. I completed that like over a year ago, and my last name is different on it because I got married since then. So,
well, that's your fault for getting married, right? So you're going to have to tell your husband, whatever his name is. No, I'm joking. Do you have a copy, or can you go in and get a copy of that certificate?
yeah, I already have it saved.
Well, why don't you just send me that with a little note with your real name kind of thing, and I'll give you the thing for it.
Right,
you don't need to redo something that you've done. So you did that without knowing that later in the year you were going to get some extra credit for it. So that was cool. I'm just nosy. Is your husband in the military?
Yes, he is.
Yeah. Well, thank you for his service. Is he, without sharing anything, if it's a secret, is he off anywhere soon? Or is he here right now?
Oh no, he's done with deployments. He's on his boat's being decommissioned, so he's not going on out anymore.
Oh, do you know those huge aircraft carriers that I drive by? Is that what happens to those poor things?
I have no clue, honestly.
Right. So, did he go and break his boat, and that's why they decommissioned it?
Well, it's like the oldest boat that they have right now, so.
Well, I'm assuming then that he's leaving the Navy, because eventually they're going to stick him on a brand new one, aren't they?
He's got like less than a year left, thank God.
Oh, okay. So he's time. You've got a big clock in the house that goes day by day. Okay. Well, I'm glad he's here, stopping bad people from doing nasty things to us. So that's cool. Right. Any other questions?
Are we able to have like a little note card of like the formula for like a Z-score?
Well done. God, I should have said that. Well done. What you're allowed. Yes. Let's tell you what you're not allowed and then what you are allowed. You're not allowed to talk to anybody about the test. That's called cheating, which is very obvious. You are not allowed to go to e-tutoring and ask them how to do the question. That's cheating, right? That's communicating with a person either through email or blogs, because that's still communicating with a person, right? So they are no-nos. Well, you probably would have figured that out anyway, right? You're not allowed to use special software. And if you don't know what this software is, you're probably never going to enter that. But there is some software out there that you can actually plug in questions and it does the answers for you, right? So don't use them, not allowed. It wouldn't matter, because if you did use them, wouldn't you only get the answer? And since I wouldn't see the working, if I don't see working, you're getting 0. Unless it's a question that I know working would, you know, you can't show me working, right? If it's pick a picture. What you are allowed to use, you are allowed to use, I would suggest really strongly, like Doris says, I would put together Z-score formulas and any kind of formula, like, do you know the upper fence and lower fence for testing for outliers? You know, anything like that. Have it in, you know, an easy to find couple of pieces of paper, right? The cheat sheet, right? I'd have it there. So that when you need to go and look at an X-score formula or whatever, a Z-score formula, whatever, oh, I forgot, a Rachel formula, right? Or a Jenny formula, you would have to, you'd have it in front of you and you're good to go. You're allowed to read anything that's on a PDF, so if it's physically written down or as an electronic PDF, you can use that. You can actually watch any video you want. Now, there's a proviso to that. If you have to watch a 20-minute video to find out how to do a question, you're going to run out of time. So don't do that. unless it's the last question and you've got half an hour to go, you could probably watch the 20-minute video and still have time to finish it, right? So I wouldn't put the video on a very high list of things I would use to help me in the test, but technically you could do it, right? PDFs are a little bit easier to use because they don't tend to be so long, right? You could probably scan through one and you know, if you need to remember a formula, for instance, that you forgot to write down, that would be a good usage of it. That was a great question, Doris. I am so glad you asked that because that could be a problem. Here's one I think I forgot to mention. Starting at 9, there will be a Zoom lesson. It won't be a Zoom lesson, there'll be a Zoom meeting. So you lot will be here and I will see you. And that will be another way, at least for those who've got video cameras, that I can tell your big brother's not behind you whispering the answers or how to do it. So that's another check on cheating. Plus, if you come across a question that looks weird, you can just hit the space bar and say, hey, I'm looking at question 14 in the homework. That doesn't make sense, or whatever it is. And I can have a look at it and say, and maybe I can explain what's going on, right? Something like that. You might just come up with my calculator and say, hey, look, it's doing error again. And I'll say, did you remember to hit the negative button and not the subtract? Right? Or something like that, you know? So I'll be there for, you know, in the same way that if you were doing an exam, wouldn't I be walking around the classroom and you would say, hey, my calculators went wonky on me, or what does, you know, I don't know what you're asking here or something. So that's what that will be for, right? So you just turn up and we're good. So I'm glad I remembered that as well.
And will your lesson PDFs still be on Canvas?
Everything should be there. Okay. I'll just drop them down to the next menu. Do you know that when you have it, I'm just going to put the obvious stuff at the top so that, you know, the people who stress out, it's easy if you keep things simple for them, right? So all you'll have is, here is where you download your work. Here is the program you can use to take a picture of it. And here's a PDF telling you what you can do and can't do in the test, right?
Yeah, that sounds helpful.
Okay, but all the chapter 1 stuff and all the PDFs will just be in the next section down. I think it's called something like college resources, isn't it, or something like that? Whatever its heading is, it'll be there.
Is there going to be anything that you haven't lectured on in the test?